Okay, let's move on to the next question. Now, this question comes up and is can stump people, if I'm honest. Question 3. The table below shows properties of different substances. Substance substance W, X, Y, and Z. Now, we don't know what substances these are unless we look at the properties. And here we have melting point in degrees Celsius, boiling point. Who can define what melting point is for me, please, in the chat section? What is melting point? How do we define that? How do we define melting point? Anybody? Not the degree. It's not solid to a liquid, that's melting. What's the melting point? The melting point is the temperature. It's the temperature, look, degrees Celsius. It's the temperature at which a solid changes into a liquid. That's what melting point is. The melting point at which a solid changes into a liquid. Boiling point is the temperature at which a liquid changes into a gas. So look, we can see the melting point of substance W is very high. The melting point of substance X is very low. The melting point of substance Y is very high. And the melting point of Z is very low. Now, straight away, I know because the melting point and boiling point of X and Z are so low, what type of bonding do they have? Can anybody tell me in the chat section? Ionic, metallic, simple, covalent, giant, or giant covalent? Because remember, there's simple covalent and just giant covalent. We're going to learn about the differences today. Well done, Tally. Simple covalent. Well done, Fatah. Simple covalent. Also, look, they do not conduct electricity. X and Z do not conduct electricity when liquid or when solid. That's because why? There are no what? Why do they not conduct electricity? There are no what? Good, that's one thing you can say. No delocalized electrons, or what else? Also, no ions free to move. Well done, Phoebe. No ions free to move. Okay, so no, they have no delocalized electrons, and there are no free ions to move, so cannot conduct electricity. Let's look at W now. W has a high melting point and boiling point, just like Y does. But look at this. W, okay, can conduct electricity when a liquid, but cannot when a solid. Therefore, what type of bonding do we think this is? Ionic, giant covalent, or metallic? Well done, ionic. The reason why, if you ever see any substance with a high melting and boiling point, and can conduct electricity when liquid but can't when a solid, that means this is because why? Why is it ionic compounds cannot conduct electricity when solid? Who can tell us? We learned this in the last lesson. Why can ionic compounds not conduct electricity when solid? Not electrons. Well done, Fatiha. The ions are not free to move. Well done, Kasar. Well done, Phoebe. The ions are not free to move. Excellent. And when a liquid, the ions are free to move, so can conduct electricity. Look at Y then. What substance, what kind of bonding do you think Y has? Good. Metallic. Potentially could be giant covalent if it's graphite or graphene, but the melting point is too low to be graphite or graphene. So it is metallic. Well done. Y is metallic. Now, what gives it away is the fact that the melting point is high, but it's not crazily high. It's not 3, 4, 5,000 degrees Celsius. Also, can conduct electricity when solid and when liquid. I just want to stress, metals have delocalized electrons. Ionic compounds do not.